focus back on.
Alright, so last time we were together, we talked about having a couple of vectors, and we talked about adding them together and multiplying them by a number. So you can look back at your notes and see how we did that. It was really, really easy. Well, it turns out that there are two ways to multiply vectors. One of them is called the dot product. This is called literally the dot product. And the other one, which we are not going to talk about, is called the cross product. In regular math, like the numbers, if I said this or this, you would do exactly the same thing, but not in vector land. In vector land, these are very, very different. The dot product is going to yield a number. The cross product is going to yield another vector. And again, we don't have time to do that one. We're going to need the dot product. So if I'm going to dot these two vectors, it's very, very easy. I'm going to take negative 7 times 0. I'm going to take negative 3 times 5. And I'm going to add them up. So again, the answer is just going to be a number. The answer is negative 15. So how do I find the dot product of two vectors? I multiply their first coordinates, I multiply their second coordinates, and I add them together. So basically, x times x, y times y, add them up. That's the dot product. Okay, now, what do we do with the dot product? Well, there are actually lots of things we can do, but the only one we have time to talk about is we're going to find the measure of the angle formed by these two vectors. So if you think about it, we can draw this vector. Negative 7, negative 3 would look like this. Negative 7, negative 3. 0, 5 would look like this. And clearly they form an angle. And our job is to find that angle. Okay? So I'm going to write something up here on the board. You probably should write it down. The dot product, E dot U, is equal to the magnitude of vector V. Remember, this notation means magnitude. Times the magnitude of vector U times the cosine of the angle between them. So the dot product, which we already know is negative 15, we already did that, is equal to the magnitude of the first vector. I think we did that the other day. Does anybody remember? What is the magnitude of the vector that goes left 7 and down 3? What's the magnitude of that vector? Square root of 58. And then the magnitude of U, well, that one's kind of easy because it's just straight up 5. So isn't its magnitude just 5? Times the cosine of the angle between them. And that's what we're looking for. We're looking for the angle between them. So the dot product, which we calculated, negative 15, equals magnitude times cosine. So would you agree that the cosine is negative 15 divided by 5 root 58? And then me find an angle, what do I need to do? I need to second cosine that number. So let's type it in. Be really careful, both of these are in the denominator. Make sure you have both of those things in the denominator, second cosine. I'm in radian mode, which of course our class is in radian mode. So I got 1.976 radians. In degrees, that would be 113, and that might make more sense to you in terms of the picture. Does that make sense? 113 degrees, Charlie?
With that or?
No. We do everything in radians. I just did that so that you could kind of see that it really is working out the way it's supposed to.
And also, on the video that we were supposed to watch over the weekend, you did a bunch of stuff that wasn't specifically in the notes.
I
Are we
did.
quizzing over that?
Yes.
Alright.
Yeah, the Moss theorem. Yeah. Okay? Thank you for watching that, by the way, Charlie.
You're welcome.
Okay. We have two more things to talk about, and that's it. One is solving triangles. Alright, so we're gonna solve these two triangles. When we say, we're gonna review tomorrow, or whatever, is it tomorrow? Yeah, it's tomorrow. We're gonna review a little bit before we take our quiz. But we need to talk about this. When we say we're gonna solve the triangle, what that means is we're gonna find every missing piece. So we are missing side S, we are missing side H, and we are missing angle C. Can you find any of those things? Oh, by the way, those are degree measures. Those are degree measures. Can you find any of those things? Angle C is easy because we know the angles add up to 180. So what would that be? That's 141, 39. Is that 41? Check my math, is that right? Now, anybody know how to start finding the sides? Charlie?
We do like some cosine, sine stuff.
Well, this one's gonna be sine stuff. That one's gonna be cosine stuff. And the reason this one is sine stuff is the law of sines looks like this. And as long as you have, like in this case, we have C and C. As long as you have one of these sets, you're gonna use law of sines. So we do have that right here. We have that set. So we're gonna say sine 41 over 10 equals, pick it, sine 58 over S. And then we could have done, and we'll need to do one way or the other, sine 81 over H. So this is the key right here to using the law of sines. The law of sines is simply proportion. And in order to use it, you have to know one of the fractions. So we knew this one. So sine 41 over 10, sine 58 over S, sine 41 over 10, sine 81 over h. And then we solve these by cross multiplying and dividing. So, squeeze it in here somewhere. Sine 41 times s equals 10 sine 58. So I'll divide by sine 41. Make sure you're in degrees, by the way. These are degree measures. So what am I doing here? 10 sine 58. Did you get 9.996? No, that's never mind. That's not right. I need to turn my calculator back. How about 12.926? How does that sound? Is that all right for S? And then I'll do exactly the same thing here. So h sine 41 equals 10 sine 81. You probably did this in geometry, maybe. Should look somewhat familiar to you. I got 15.055. Law signs, super simple. But it only can be used when you have this right here. When you have one of your fractions. So when you look at this next triangle, you see that the law of signs, while it is true, absolutely true, that sine 52 over h equals sine c over 12, that is true. I just can't solve it because I got too many variables in the wrong places. So if the law of signs doesn't work, then we'll do what Charlie said, we'll use cosines. For this problem right here, for this problem, the law of cosines looks like this. H squared equals 10 squared plus 12 squared minus 2 10 12 cosine 52. Now you are starting to get a little bit freaked out. Oh my gosh, Mrs. Ford. It's really easy. Celeste?
For the problem before, did you just divide 10 sine 58 by sine 41?
I think I did.
Because I got like negative 62.
Are you in degrees or radians?
I should be.
No, we're in degrees. These are degree measures. These are all degree measures. That couldn't be a radian measure because in radians, the angles have to add up to pi, which is 3.14. So yeah, these are degree measures. Now, I'm not saying I couldn't have made a mistake, because I could have, but make sure you're in degrees.
Is everything else in radian though?
What?
Like everything else we're gonna do is in radian?
Yeah. Yeah, remember, this is this odd unit. And I should be putting degree marks on these, so make that emphasis. All right, well, let's go ahead and type this in, and then we'll talk about like your formula if you're taking notes for the law of cosines. Let's go ahead and type that in. So we got 10 squared plus 12 squared minus 2 times 10 times 12 times cosine 52. Now remember, when you get all that typed in, that is h squared. So you need to square root it. I got 9.810. Anybody else get that? No? Yes? Now, what's the good news at this point? What does that mean? That means I can use my law of sines, the easier one. So maybe I'll say sine 52 over 9.810 equals sine S over 10, for example. So sine 52 over this equals sine S over 10. Now be careful. What am I going to have to type in on my calculator? Do not type in this fraction as the answer, because the fraction isn't the answer. What am I gonna have to do? Second sign it. Yeah, you need to second sign that fraction. To get angle S, to get an angle, you need to use your inverse button every time. So second sine, 10 sine 52 divided by, I got 53.444. And then of course angle C is a no-brainer because the angles have to add up to 180. So we can find that last one. 74.556. Let me write down the law of cosines for you so you have it. This is the pattern. The letters, of course, are going to depend on your actual problem, but in general, the law of cosines says at the side, c squared equals a squared plus b squared minus 2ab cosine c. Capital letters refer to the angles, lowercase letters refer to the sides. So c squared equals a squared plus b squared minus 2ab cosine c. Notice that on the ends of the equation, you have the same letter. So your side squared's over here and then your cosine angle is here. And then all this stuff in the middle is the other two sides. So if I have a different triangle and I said a squared equals, can anybody tell me what that would be? What would a squared equal in the triangle? B squared plus c squared minus 2bc cosine A? Charlie?
Couldn't it also be like a squared equals c squared minus b squared plus 2 ab cosine c? Like just rearrange the first equation?
Rearrange this one?
Yeah.
Okay, but then it would be negative a squared.
Yeah, but what if you divide by 1, negative 1 on both sides?
They're still part of this.
You absolutely can rewrite this equation however you want to,
Okay.
okay? I'm not sure why you would ever do that, but yes, this is true no matter what way you arrange it.
Okay.
So if you want to move everything over and have b squared over here by itself, that is totally 100% fine.
Oh, I see what you're doing. I understand. Okay.
Yeah, these are the same formula but solving for different things.
thought, oh, okay.
These are not the same equation.
You're not the same formula,
Not
okay.
the same equation, no. The same, this is the law of cosines. So, one more time, if I did m squared, my triangle was MNP. M squared would be n squared plus p squared minus 2, it's always minus 2, np cosine m. That's the pattern of the law of cosines. I discourage people from memorizing it for the very reason you're talking about, Charlie. If you know the pattern, the way it's set up, that's the best thing. Okay. All right, let's do one more quick triangle and then we'll have to be done with that. Let's do letter C. Now you have at your disposal two rules, or two laws. We have the law of sines and the law of cosines. Which one is going to be applicable in this problem?
Law of sine?
Is it?
Yeah.
Remember, to use the law of sines, I would have something like sine C over 12 equals sine H over 14. That is absolutely true. That is a true statement, but is it solvable, Charlie?
No, it's not.
We got too many variables in there. Remember, to use the law of sines, you have to have a set. You have to have an angle in its side. If you don't have that, then you're going to use the law of cosines, this, okay? So let's decide, let's find angle H. Doesn't matter, we just have to find one, we'll just find H. So if I'm gonna use the law of cosines, this guy right here, to find H, then on this side is gonna be 14 squared, and on this side is gonna be cosine H. That's the way it's set up. And then what's going to be in the middle here? What is the middle part of the law of cosines? Charlie?
12 squared plus 10 squared minus 2 times 12 times.
Yep, and the 10 and the 12 can be in either order, that doesn't matter. That's it exactly. Now we have to solve that, and we gotta do it carefully because we can't just type all that stuff in. Because this part's hooked to a cosine. So I'm gonna do 14 squared minus 12 squared minus 10 squared. So I'm gonna move all this over, and I got negative 48 equals all the rest of this stuff. You with me, folks? I just subtracted these things over. Now, all of that times together is negative 240. So would you agree that cosine H is 48 over 240? Quickly, do you agree with that? So then I'll second cosine, right? And I will have angle H. And then, Charlie, as soon as I got angle H, then I'll have my set, and I can use the law of sines. Okay? Well, I never got around to checking your homework. Well, here's your practice for the night. Where did we leave off? We don't have very much, so we're going to finish 7, do 8, 9, and 10. Finish 7 and do 8, 9, and 10. Okay, have a great day. Finish 7, do 8, 9, and 10.
Thank you.
That isn't very many problems, actually. Use your notes.